Welcome back to the video lecture series for Introduction to the Art of Programming Using Scala. In this video, at the end of the last video, we were working on our binary heap. We had just implemented the dequeue, so we had everything written, and then we decided to test it. So we had our heap priority queue. We had made it so that it has the ability to grow. We had written the dequeue, and then for the testing, I just copied over our previous sorted doubly linked list based priority queue and pasted it in and changed it so that when it created the priority queue, it used the heap based version instead of the doubly linked list. And that was the only thing that we changed in the code. And then when I ran this, we had 3 of our tests fail. Okay, so the add 3, the add remove 3, add remove 3, and add remove 100. So the problem that we run into on this first test is we add 5 to 7, and when we dequeue or when we peek at it, we see the 7. We're supposed to see the 7 and we don't. We got the 2 instead. Now, something to note there is that we were looking for the highest value and we got the lowest value. What about for our add remove 100? We say that we expect this number, which is a very large number, and we got this number, which is a very, very small number. So we're noticing a trend here, that it appears that when we're the order of these things, and so one bug would be this could be just completely random. The other bug could be that it's just they're coming out in the quote wrong order, or it could be that the test we copied over wasn't quite right. So if we go look at this one line that we changed, it's possible we didn't change enough. So for the doubly linked list, we were passing in a function called LT for less than. Here we're passing in the heap priority. We're passing in something that's supposed to be high priority, or the higher priority. So this is expecting that that 7 should be a higher priority, except for the fact that what we're passing in says that less than it gives you higher priority. So why don't we switch that around? Okay, so that we're saying that now when the first thing is greater than the second, that is the high priority. We run that, oh, and now we're at a green bar. Okay, so that was actually the only problem. The problem was not inside of our heap priority queue. All of the code that's written in here is passing these tests just fine. I won't say it's perfect, but it definitely passes the set of tests that we had. However, when we switched from priority queues, we switched the order of the operator that we passed in. I could strongly argue that was a poor design choice, though I'd probably argue that the one we did previously with the doubly linked list might have been the poor design choice, and it's better to pass in a function that gives you that tells you when something is a higher priority, but we're not changing that at this point. So that's it for our priority queue. We have a functional heap-based priority queue, and